Hi guys, welcome to today's video. We're going to be doing some Pythagorean theorem. So let's go ahead and look at number 1. We're on page 1 of your Unit 5 packet. So here we are, number 1. First thing we always want to do is locate the hypotenuse, because your hypotenuse is always going to be C in the Pythagorean theorem. So let's go ahead and label that C. And then these two will have to be the legs. So this can be either A or B. So I'll make those orange. Okay. So we're going to do A squared plus B squared equals C squared. So here we're given C, we're given the hypotenuse, so C squared is actually going to be 13 squared. A squared is going to be 12 squared. And then B squared, that's what we're solving for. That's the missing leg. Alright, so we have it all set up. We have our A squared, our B squared, and our C squared. So 12 squared is 144. 13 squared is 169. Okay, so now here's where when you have C and you have either A or B, you have to subtract. And you get B squared equals 25. So the area, the square of this leg is 25. So to find the side length, you have to take the square root of both, and then B equals the square root of 25, which is 5. So this missing leg is 5 inches. Okay. Number 2, always, always, always locate your hypotenuse first and label it C. Okay, the biggest mistake that I see you guys making is that you're not putting the numbers in the right spot in the Pythagorean theorem. These two, these legs, always have to be A and B, and this side always has to be C, the diagonal. Okay, so this will be A and this will be B. A squared plus B squared equals C squared. Alright, A is 4, 4 squared. B is 3, 3 squared. C is unknown. Well, actually, if you remember the squares that we made in class on Monday, this is the one that we did. 4, a square of 4 is 16. 3 square is 9. 16 plus 9 is 25. So the area of the hypotenuse square is 25, so you have to take the square root to find the side length. And the square root of 25 is 5. So C equals 5 miles. Okay, so look at the difference. When we were searching for the leg, we had to subtract. When we were searching for the hypotenuse, we had to add at this step. Okay? That's why I'm telling you it's so important to locate your hypotenuse first. Okay, so 3 and 4 have some decimals, but that's okay. You just do it the same way. So I already wrote this one in. So your hypotenuse is 14.7. So that's C. So I had to put that here. And then your legs are 11.9 and X. So I had to put 11.9 squared, and then this is B, so just B squared. So now you just square the decimals. You definitely need a calculator for this. So 11.9 squared is 141.61. Okay. 14.7 squared is 216.09. Okay. So here you have to subtract. So that number minus okay. So B squared equals 74.48, and then you take the square root to find the side length. And it's approximately, let's change that, approximately 8.6 for B. Okay. All right. Locate your hypotenuse first. This one's upside down, but that's okay. Your hypotenuse is always across from the right angle. All right. So label this one C, of course, because that's your hypotenuse, and the other ones can be A and B. So A is 6.3 squared plus B squared equals 15.4 squared. 6.3 times 6.3 is 39.69. Plus B squared equals 15.4 squared is 237.16. Okay. They're on different sides, so you have to subtract. $237.16 minus 39.69 is 197.47. Bring down the B squared and take the square root of both sides, which is approximately 14.1, or just 14, whatever, we're approximating. Okay. So I told you guys in class to skip these two down here. This should be enough, okay? Because 5 and 6, we're going to have to leave the answer in simplest radical form, which we can totally do. It just means we don't have to take the square root. That's it. So let's identify our hypotenuse first, like we always do. So here it is. It's across from the right angle. That has to be C. And the legs have to be A and B. Okay. Write your theorem and then plug it. 13 squared plus B squared equals 15 squared. So we get 13 squared is 169 plus B squared equals 225. They're on different sides, so we have to subtract. $225 minus 169 is 56. Okay, so now we have to leave this in simplest radical form. So we are taking the square root. This is some good practice for what we just did. If it says to leave it in simplest radical form, you have to make a factor tree. That's what that means. So for 56, we do 9 times 4, 2 times 2, and 9 is 3 times 3. Wait, it's 9 times, it's not 9 times 4, it's 9 times 6. Sorry guys, long day. 6 is 3 times 2. Should be using a pencil, I don't know why I'm not. Okay, so you have a pair of 3s, so 1 3 goes out, and then 3 times 2 on the inside is 6. So it's, this side is 3 square root 6. You can circle it down here because I ran out of room. Okay. That was fun. Let's do that again. Identify your hypotenuse and identify your legs. Your hypotenuse is always C. So for this one, C is going to be 16. and the legs are A and B. Okay, so A is 8. So 8 squared plus B squared equals 16 squared. So 64 equals 256. That's 16 squared. Again, they're on different sides, so subtract 64. That's 192. We have to leave this in simplest radical form, so I have to go down here. I'm going to make a factor tree for 192. Okay, so I'm going to use 96 times 2. And I'm going to use 48 times 2. 48, we can do 6 times 8. 3 times 2. 4 times 2. And then 4 is 2 times 2. Sorry guys, I'm going kind of fast because I want to get this video out before buses. Okay. So we have a 3, and then 1, 2, 3, 4, 5, 6 2s. Alright, so pair, pair, pair. So since I have 3 pairs of 2s, I'm going to have 3 2s on the outside, and then 1 3 left over on the inside. So 2 times 2 times 2 is 8. So it's 8 square root 3 for this one. That's what you do only if they tell you to leave it in simplest radical form. Otherwise, you would just put it in the calculator and put the decimal version. But sometimes, you know, math teachers like to be a little extra. Alright guys, so you can skip number 7 and 8. So this is a lot of work for this page anyway, and I will see you tomorrow.